Hello students, in this lecture we will see a new concept of source transformation. I will introduce this concept and also will solve a numerical on source transformation. Now you are aware of that there are two types of sources. One is voltage source and another one is current source. Now what do you mean by source transformation? Let's say across A and B terminal you have one voltage source in series with a resistance. Then you can convert that voltage source into a current source whose value will be, current source value will be V by R with parallel resistance. So this will remain terminal A, this will remain terminal B. This is one type of transformation where you are converting voltage source into a current source. Similarly, you can convert current source with a parallel resistance into a voltage source with a series resistance. In that case, you will be knowing I and R, and you have to calculate V by the formula of Ohm's law, and that is given as I into R. So while transforming this thing, the value of resistor will always remain same. Only the value of voltage can be calculated as I into R, or the value of current can be calculated as V by R. One more thing you should remember, that the orientation of the resistance mentioned in the original circuit should remain same in the transform network. What do you mean by this? Now in this circuit the resistance R is mentioned is oriented vertically. So over here again in transform network the resistance has to be mentioned vertically. The current will be moving upward. How to determine the direction of the current? Now towards A, positive of the supply is connected. That's why the current is moving towards A. Now when you talk about the second circuit, let's say this is terminal A and B. Voltage source is in series with a resistance. So this can be converted into a parallel combination of current and a resistance. The value of resistance will remain same and current value you can calculate by formula V by R. Now you can see here positive is connected towards B. So that means the current is moving towards terminal B. Let's say resistance is 2 ohm and the voltage source is 5 volt. So here we will have resistance as 2 ohm and the value of the current will be 5 by 2, that is 2.5 ampere. Now we'll start solving the numerical on this. So here they are saying convert the circuit given to a single voltage source with a resistor. If you see this circuit diagram, there are two sources and two resistances. Now instead of this they want only one voltage source and one resistor. Okay. So what you have to do? So while solving the numerical on source transformation, I will give one simpler technique over here. First we have to build a strategy. So which source has to be converted into which type of source. So what you have to do, I will keep A as it is, B as it is. You remove the voltage source. Remove the voltage source means what? Voltage source you have to replace by short circuit, and if there are current source you have to replace them by open circuit, and you have to draw a rough diagram for this. So what will happen? 4 ohm will be there as it is, 10 volt will go, and here you will have 8 ohm resistor. So now if you see this thing, A across A and B, 8 and 4 they are connected in parallel. If I ask you to calculate the resistance between A and B, 8 and 4 will be in parallel. So remember, when you have parallel combination of the resistances, you will prefer current sources over there. So parallel combination is there, you have to make current sources over there. And if there is a series connection of the resistance, then you require voltage sources. Remember this thing, you can easily solve any numerical on source transformation. So in this numerical 8 and 4 ohm, these resistances are in parallel. So we require current sources to be present in these branches, two branches. So I will go for the source transformation. Remember this thing, 8 ohm the value will remain same. Even for the 4 ohm the value of the resistance will remain same. So this is across A and B. Of course two more current sources will come over here. Now when you talk about 15 volt and 8 ohm, you will have a current source over here, and the direction of the current source will be moving upward because the positive is connected towards terminal A, and the value of this current source is 15 by 8. So that turns out to be 1.875 ampere moving up. What about the current source for transform network of 10 volt and 4 ohm. So 4 ohm will be as it is. Positive is connected towards A. So again the current will be moving upward, and the value of this current source is given as 10 by 4. So that is 2.5 ampere. Now across A and B, this is terminal A, as there is no element over here. This is terminal B. So 8 and 4, they are in parallel. So you can have parallel combination of 8 and 4, and 8 and 4 can be solved as product by sum. So 32 by 12. So that turns out to be 2.67 ohm. So parallel equivalence is 2.67 ohm. And two current sources, they are in parallel and moving in the same direction. So you can add them. Current sources in parallel can be added, while the voltage sources in series can be added. So you will have current source value as 1.875 plus 2.5. So that turns out to be 4.375 ampere moving upward. Problem statement says that you have to calculate between terminal A and B single voltage source with a series resistor. So final transformation is required over here. Between A and B, we will have 2.67 ohm resistor as it is, and in series with a voltage source. Now what about the polarity of the voltage source? Current direction is towards A, so A terminal is positive, B will be negative. Towards A you will specify positive terminal. And the value of voltage source is given as 4.375 into 2.67. So that turns out to be 11.67 volt. So here I am writing 11.67 volt. So the given circuit can be replaced by a resistance of 2.67 ohm in series with a voltage source of 11.67 volt. So that is all about this numerical. Remember this thing, that whenever current sources are in parallel, you can add them. Similarly, when voltage sources are in series, you can add them according to their polarity. Thank you.